Hello everyone, welcome to Robotics 2. I'm going to do a second example of finding the velocity of a particular point in a manipulator. This time I'm going to use a cross product. So the way we're going to do this is we're going to go Ri is equal to Rb. This example is going to be pretty quick because I'm basically just going to go through it. I'm not going to go into too much of the backstory of how this stuff works. Hopefully you've been introduced to it. This will just be a worked example. So the angular velocity vector of I, with respect to I from B to I, cross B, Ri, the position. We know that B omega I is equal to 0, 0, theta dot. This is because we only have a rotation around the z-axis of theta. So then B omega I will be theta dot in the z position of this vector. This also comes from the skew symmetric matrix of BB omega I, which is equal to ITB transpose of ITB dot. And this is kind of the backstory that I was talking about, so I'm not going to explain it very much, but if you watch my first example, you'll see where you can get ITB and ITB dot, and solving that all out will give you this vector right here. So this is basically a shortcut. If you realize that you're rotating around this single axis, you can just go ahead and skip to this vector and then do a cross product, which saves you this matrix multiplication over here. Alrighty, so going ahead and going on with this, Ri dot is equal to 0 because IIRB is a set of constants just from here to here, which is going to give you 0, a vector of zeros, plus cosine of theta minus sine of theta 0, sine of theta, cosine of theta 0, 0, 0, 1. Okay, so this is rotation about z. What I'm going to do is basically finish this whole deal up. Times 0, 0, theta dot. This is a transformation matrix right here. This is what I just found. Cross with 3, 0, 0, which is BBRI, which is this vector from here to here. X-axis, 3, 0, 0. Like I said, I was going to go through this pretty quick. Multiplying this all out, you get cosine of theta, negative sine of theta, 0, negative sine of theta, cosine of theta, 0, 0, 0, 1, and you get 0, 3 theta dot, 0. This is all matrix, so on and so forth. I'm sorry, that's positive. Alrighty, and this will give you as a value negative 3 theta dot sine of theta, 3 theta dot cosine of theta, 0. Just like that. Which is the exact same answer we got in part 1 of this problem, where we did not use the cross product. Instead, we just took the differential of the transformation vectors, basically this little piece up here. We found this and multiplied it by all this stuff out. And you can go ahead and look at that example to see how it is. The cross product, it's another method based on either what you have or how you like to solve the problem. Cross products, some people have trouble with these. They're really not that bad, especially when you're just dealing with two vectors, but it's a point of preference almost. Alrighty, I'll do another example of this with a different setup for the cross product, and we'll see how that goes out. That'll be part 3.